Hello and welcome to Calming Oxidative Inflammation, supporting the bioenergetic foundations of longevity. My name is Adair Anderson. I'm the product marketing educator at Vibrant Wellness. I'm also a registered dietitian nutritionist with a private practice called Eating with Integrity, where I resolve functional gut disorders and help clients get back to living their best life. I earned an undergraduate degree in biochemistry, a master's degree in clinical nutrition from Adair University, and I've also completed advanced training in functional medicine through the Institute of Functional Medicine. Here's our agenda. First, I'll give an overview of oxidative stress. Then, I'll introduce Vibrant's oxidative stress profile. We'll follow a patient case to see how targeted interventions rooted in testing, not guessing, can restore redox balance, support mitochondrial health, and promote lasting resilience. We'll end with synergistic testing and key takeaways. So, what is oxidative stress? Oxidative stress is when the body's in a state of stress or inflammation as a result of an imbalance between the generation and buildup of reactive oxygen species, or ROS for short, and the ability to eliminate these reactive byproducts through both innate biological systems and dietary antioxidants. Said another way, oxidative stress occurs when the body is unable to keep up with the accumulation of ROS due to inadequate intake of antioxidants, poorly functioning endogenous antioxidants, and/or a diet and lifestyle that generates excessive reactive oxygen species. What creates free radicals and contributes to the oxidative stress load in the body? Well, 3 things. Number 1, normal cellular processes. Number 2, inflammatory processes. And number 3, exposure to dietary and environmental oxidants. When I say normal cellular processes, I mean the process by which your mitochondria turn carbohydrates, fat, and protein into energy. Thanks to Dr. David Haas, I've got an analogy for you. Think of your mitochondria like a car with an internal combustion engine. Every time you drive the car takes a little bit of oxygen, mix it with the fuel, burns that fuel, and out of the tailpipe comes a little bit of water, some carbon dioxide, and some energy that propels the car forward, but also some smoke and soot. That's basically what mitochondria do too. They bring in food energy, mix it with oxygen inside the internal combustion engine of the mitochondria, producing some water, some carbon dioxide, which of course we breathe out, and also some energy, which is the ATP that fuels the cell. But we also produce some smoke and soot, which is the reactive oxygen species. It's well known that young and healthy mitochondria burn fuel cleaner than older and/or damaged mitochondria. Specifically, as mitochondria turn food into energy, they create some ROS. Those ROS can cause oxidative damage, which includes mutation to mitochondrial DNA. This, of course, leads to mitochondrial dysfunction, which drives aging. Then, those aged mitochondria don't burn fuel as cleanly, thus producing more ROS, and the cycle goes on and on. In short, aging causes a decline in mitochondrial function, which amplifies and perpetuates this cycle. And this is the free radical theory of aging, which aligns with our increased risk for chronic disease as we age. Superoxide is an example of mitochondrial smoke and soot, and it's primarily generated by electrons escaping from the electron transport chain complexes 1 and 3. In fact, 1 to 2% of the oxygen consumed by our mitochondria is converted into superoxide, which results in about 1 kilogram of ROS produced from cellular respiration each year. The consequence is about 100,000 oxidative taps on mitochondrial DNA per cell per day. Which is why everyone has a fleet of endogenous antioxidant enzymes that help clean up the free radicals produced by normal metabolic processes. We'll of course dive into these in more detail later, but I wanted to highlight a few you might recognize now, like superoxide dismutase, which neutralizes that superoxide, as well as catalase and glutathione peroxidase. The second source of free radicals that contributes to oxidative stress load in the body are the ROS created during inflammatory processes. Innate immune cells like macrophages and neutrophils actually produce ROS to kill invading pathogens. What happens is that macrophages phagocytose a bacteria, virus, or yeast, and then once encased in the phagosome, the macrophages release ROS into the phagosome, irreversibly oxidizing, thus damaging all the cellular structures of the intruding pathogen. And this is a good thing. You want your innate immune system to be able to vanquish pathogens. So, are free radicals always harmful? No, free radicals are not always harmful. Instead, ROS are actually essential signaling molecules required to promote health and longevity. In fact, according to the article cited on this slide, turning off the mitochondrial ROS signal impairs the lifespan extending and health promoting capabilities of reduced calorie uptake, glucose restriction, and physical exercise. I think this graph shows the balance really well. If you have a little bit of oxidative stress, recognized on the left as priming, it turns on NRF2, which then goes on to create a whole host of protective antioxidant enzymes like SOD and GPX. In other words, a little bit of stress equals a good response. Now, if you have a little bit more oxidative stress, then you turn on NF-kappa B, and inflammation starts to take place. You start to get tissue damage, etc. And this better get resolved or you're going to have a long-term problem and produce even more oxidative stress. And then if you go on to have a lot more oxidative stress than you can handle, let's call this extreme levels, then you turn on activator protein 1, sending the apoptosis signal to the cells so they commit programmed cell death. In other words, the dose makes the poison. So, what causes higher levels of oxidative stress than our bodies can handle? Well, it's the exposure to dietary and environmental oxidants. This includes a hypercaloric diet, because when you overeat, you're essentially flooding the engine and getting more of that smoke and soot. Also, hyperglycemia. Anytime you have a spike in blood sugar, that is an inflammatory event. Additionally, eating foods high in advanced glycation end products like fried foods and many fast foods contributes to this load, as well as foods that contain pesticides and herbicides, also processed foods, and the standard American diet lacking protective phytonutrients and natural antioxidants. This also includes lifestyle choices like smoking cigarettes, which are full of mitochondrial poisons like carbon dioxide and cyanide. Also drinking alcohol, which impairs liver biotransformation, leading to more toxic intermediates. Medications, especially polypharmacy, which increases liver burden. And the two exercise extremes, either a sedentary lifestyle or, on the other hand, excessive exercise. Then there's environmental factors like UV radiation from the sun or toxicants like heavy metals, environmental toxins beyond what ends up in our food like cleaning products and exhaust from automobiles. Also mycotoxins, which can be found in both foods and water-damaged building materials. And PFAS chemicals, which are found ubiquitously in the clothes we wear, the tools we use, and the air we breathe. To summarize, as illustrated on the left, it's possible to be genetically predisposed to oxidative stress due to unfortunate genetics, resulting in poorly functioning antioxidant enzymes, but protected by a nutrient-dense diet and healthy lifestyle, such as getting ample sleep, managing stress, eating the rainbow, and getting regular moderate exercise. As illustrated on the right, it's also possible to have fully functioning endogenous antioxidants, but so many pro-oxidants in your diet and lifestyle that your body just can't keep up. In other words, your genes aren't the only factor impacting oxidative stress. Like with so many chronic diseases, your diet and lifestyle choices can push you in the direction of health or the direction of dysfunction and disease. So, how do you measure your patient's genetic risk versus their lifestyle choices impacting their oxidative stress load? Good news, there's now a test to measure this balancing act between diet and lifestyle versus genetic predisposition. Vibrant Wellness's oxidative stress profile evaluates 16 markers of oxidative damage, 32 single nucleotide polymorphisms, or SNPs, providing insight on antioxidant capacity and cellular resilience. Combining these two marker sets provides insight into free radical activity, inflammation, and mitochondrial function, and supports targeted strategies for reducing oxidative stress and promoting long-term cellular health. The oxidative stress profile includes two panels, antioxidant genetics and oxidative damage markers. The antioxidant genetics panel is an easy at-home saliva collection that uses gold standard RT-PCR methodology to measure the 32 SNPs impacting your oxidative stress load. The oxidative damage markers is an easy at-home urine test. that uses LC-MS, also gold standard, to measure 16 markers of oxidative damage eliminated in the urine. While creating the oxidative stress profile, Vibrant's research and development team read hundreds of scientific studies to learn which specific SNPs impact your oxidative stress and which specific damage markers are the best indicators of oxidative stress damage to DNA, RNA, lipids, and proteins. Then, since they'd already done the work, they decided to write and submit a review article on the topic. This article is now peer-reviewed and published. I've highlighted my favorite parts of the abstract here and added a QR code where you can access the free full text. So instead of doing a simple report walkthrough, let's make this more interesting by reviewing a case study. Meet Becca. Becca is a 37-year-old female who is 5'6" and weighs 150 pounds, making her BMI 24.2. She has a high-stress job as an attorney working towards partner in a law firm. She only sleeps 5 to 6 hours a night, and it's often interrupted. She has no regular exercise routine. She eats a standard American diet that's high in processed and fried foods and low in antioxidants. She reports regular alcohol intake of 3 to 5 glasses of wine per week to help her with the stress. However, she does stay hydrated, drinking from plastic water bottles multiple times per day because her company provides those, and uses conventional beauty and personal care products daily. Becca complains of persistent fatigue and brain fog, especially mid-afternoon. She has mild anxiety and gets headaches several times per week and reports joint stiffness, especially in her fingers and knees, both of which she manages with NSAIDs. Becca heard about Vibrant's oxidative stress profile online and came to me wanting to order the test. And you know there's no arguing with a lawyer. So we ordered the test, and here's what her results showed. Becca has 14 SNPs that contribute to a genetic predisposition towards elevated oxidative stress, including 7 elevated risk SNPs and 7 partially elevated risk SNPs. What does this look like exactly? Well, according to the flow chart included in the oxidative stress profile summary, the enzyme glutathione S transferase, or GST, plays an important regulatory role in detoxification by converting free radicals into soluble extracellular toxins so they can be eliminated from the body. However, because Becca has an elevated risk GST variant, see how the GST has a red rectangle around it? That variant can slow glutathione conjugation, resulting in a buildup of those free radicals. Meanwhile, when Becca's mitochondria make superoxide, her superoxide dismutase enzymes can turn superoxide into hydrogen peroxide. However, Becca has 2 elevated risk SOD variants, so she is likely unable to get rid of all the superoxide she creates, resulting in increased oxidative stress. It's also worth noting that SOD1 and SOD3 require copper and zinc, so ensuring Becca has adequate intake of copper and zinc could help her elevated risk SOD1 and SOD3 enzymes function better. Thankfully, Becca's SOD2 enzyme is working optimally, so she's probably converting some of her superoxide into hydrogen peroxide. However, excess hydrogen peroxide is not great either, which is why we have 2 enzymes to turn hydrogen peroxide into water, and that's catalase, or CAT, and glutathione peroxidase, GPX. Unfortunately, again, Becca has elevated risk variants for both catalase and glutathione peroxidase. Thus, she has a difficult time converting all that hydrogen peroxide into water, which means even more potential for oxidative damage. For the sake of time, I won't explain all 20 elevated risk enzymes across the 32 SNPs, but I will point out that the interpretive comments populate for all elevated risk SNPs, explaining the risk associated with each. Moving on to oxidative damage, Becca is currently eliminating 9 oxidative stress biomarkers across all 5 categories, including markers of lipid peroxidation like F2 isoprostanes, markers of DNA damage like 8-hydroxyguanosine, the marker of RNA damage 8-nitroguanine, the protein oxidation products dityrosine and nitrotyrosine, and advanced glycation products CML and CEL. And of the 9, 8 are moderately elevated and 1 is highly elevated. When I showed Becca the summary of the oxidative damage markers in this helpful infographic, she was surprised by how much damage was occurring to her DNA, RNA, proteins, and lipids. That surprise turned into motivation when we looked at her oxidative damage score and saw it was in the red, indicating accelerated aging. The oxidative damage score is calculated using the results from all urine damage markers tested, applied to a linear regression model, and displayed with respect to the age group. So the x-axis here is the age, and the y-axis is the oxidative damage score. A score in the green represents a normal score based on the 50th percentile of the population, indicating the patient is aging at or slower than chronological age. A score in the yellow indicates a moderate score falling between the 50th and 90th percentile, and a score in the red represents accelerated cellular aging compared to the relatively healthy reference population. So while Becca's only 37 years old chronologically, her oxidative profile looks similar to that of a 57-year-old. To help balance oxidative stress load per genetic predisposition and current damage markers, the oxidative stress profile includes personalized supplement suggestions. Becca's personalized suggestions include 75 milligrams of vitamin C, 55 micrograms selenium, 600 IUs vitamin D, 10 milligrams lutein, 22 IUs vitamin E, and 500 milligrams quercetin daily. The report comments affirm these supplements support the function of her glutathione peroxidase and superoxide dismutase enzymes and may also increase thioredoxin 2 levels. So, I put Becca on these supplements, and it was easy for her to start taking them to support her endogenous antioxidants and normal cellular processes. And they helped a little, but of course they didn't address the root cause of her oxidative stress load. One of the root causes of Becca's oxidative stress load was her diet. Since she'd been eating the standard American diet, we started her on the Institute for Functional Medicine's Core Food Plan, which takes elements from the Mediterranean and paleo diets to encourage eating nutrient-dense whole foods. A major focus of the Core Food Plan is replacing processed foods with vegetables, fruits, legumes, and whole grains. It also includes healthy fats like olive oil, avocados, nuts, and seeds. I also specifically recommended Becca eat cold water smash fish like salmon, mackerel, anchovies, sardines, and herring twice a week to get her omega-3 fatty acids, as well as eating protein and veggies before carbs to help balance her blood sugar, mood, and reduce her carb cravings, and to specifically minimize sugar, fried foods, and refined carbohydrates to mitigate glycooxidation. Remember, Becca's results showed elevated levels of advanced glycation end products CML and CEL. Advanced glycation end products, or AGEs for short, are formed when proteins and lipids become non-enzymatically glycated after exposure to sugars. You've probably heard of the Maillard reaction, where sugars and amino acids get stuck together during the heating process, creating delicious caramelized flavors. For example, when you take the amino acid lysine and heat it next to glucose, you get fructose lysine. However, when you add a dash of oxidative stress to fructose lysine, it turns into the dangerous advanced glycation end product called carboxymethyl lysine, or CML for short. CML is probably one of the most measured and well-described advanced glycation end products out there. Remember when I said that ROS are created during inflammatory processes and that macrophages produce those ROS to kill invading pathogens? Well, unfortunately, bacteria aren't the only things macrophages perceive as dangerous. AGEs have a molecular structure that looks to the body a lot like a potentially dangerous microbe. So macrophages take them up through phagocytosis and produce the same ROS they would had they eaten the pathogen. In other words, as Dr. Roundtree explained in the ASMCP course, eating sticky buns can increase your oxidative stress score. When I explained this to Becca, she was convinced to minimize sugar, fried foods, and refined carbohydrates to mitigate glycooxidation. Becca and I also talked about the importance of sleep. Remember, she was only getting 5 to 6 hours per night. I showed her the part of Vibrant's Oxidative Stress Profile Interpretive Guide where it says, evidence suggests that individuals with less than 6 hours of sleep per night exhibit significantly higher levels of oxidative stress biomarkers compared to those with adequate sleep. I also emphasize that a solid 7 to 9 hours per night is a key ingredient in reducing oxidative damage. This led to a discussion around why Becca can't sleep, Turns out she lies in bed analyzing everything that happened during the day and planning for the next day. So I took the opportunity to talk with her about turning off her mind using stress management techniques like thought stopping, meditation, and breathing exercises. I also encouraged her to work on sleep hygiene, so winding down 2 hours before bedtime, turning off bright overhead lights, avoiding screens before bedtime. So she worked on that for a while. She even bought an Oura ring to get immediate feedback on lifestyle choices impacting her sleep. After 2 months, she was sleeping better and feeling better. These significant changes Becca made to her diet and lifestyle helped her lower her oxidative damage score from 57.6 in the red to a score of 46.5 in the yellow. However, she was very motivated to get into the green. So I introduced her to Sydney Baker's TAC rules. Rule number 1, if you're sitting on a TAC, it takes a lot of aspirin to make the pain go away. In other words, it's difficult to heal if you don't identify the root cause of your symptoms. Rule number 2, if you're sitting on 2 TACs, removing one does not necessarily result in a 50% reduction in symptoms. In other words, sometimes there's more than one root cause contributing to your symptoms. Said another way, the Oxidative Stress Profile test provides a 30,000-foot overview of what's going on in the body, quantifying current oxidative stress markers alongside genetic predisposition. Therefore, synergistic testing, like Vibrant's environmental toxins, mycotoxins, heavy metals, and PFAS chemicals tests, can uncover additional details about oxidative stress load root causes. So, we ordered the total tox burden plus PFAS chemicals tests to investigate Becca's exposure to mycotoxins, heavy metals, environmental toxins, and per and polyfluoroalkyl substances. Results indicated that Becca had moderately elevated levels of nickel, which can be due to contaminated food, jewelry, cosmetics, keys, cell phones, paper clips, electrical equipment, eyeglass frames, and clothing fasteners. So she got to work figuring out where she was getting nickel exposure. It ended up being her jewelry, which was an easy thing for her to stop wearing, and an excuse to buy some new non-nickel jewelry. We also increased her dose of vitamin C because vitamin C helps mitigate the oxidative stress induced by nickel exposure. She also had high levels of BPA, which has been shown to inhibit mitochondrial complex 2, as well as elevated butylparaben and DMDTP, the latter of which is an organophosphate pesticide and also a neurotoxin. This motivated her to replace her conventional body care products with cleaner options found via the Environmental Working Group's Skin Deep database. She started buying organic produce, especially the fruits and vegetables on the Environmental Working Group's Dirty Dozen list. She also agreed to start using an insulated metal water bottle instead of the reusable plastic bottles at work, and to avoid touching receipts, which are both a common source of BPA exposure. Thankfully, she didn't have any elevated mycotoxins. And as with the oxidative stress results, the total tox burning results motivated additional changes and resulted in improved energy. But she was still experiencing headaches and brain fog. She told me she wanted to do a detox to remove these toxins from her body, and I told her that she first had to stop drinking the 3 to 5 glasses of wine per week, explaining that there's no reason to spend money washing your car if you're just going to drive it through the mud again. And that is when Becca finally stopped drinking wine. Her PFAS chemicals results indicated elevated levels of PFAS used in nonstick cookware, kitchen utensils, and food containers. So, Becca invested in a new frying pan and silicone utensils and started dining out less, both of which helped reduce her PFAS exposure. I also pointed out the report comments, which all affirm that, quote, supporting the body's natural detoxification mechanisms through adequate hydration, a nutritious diet, and regular physical activity may aid in eliminating PFAS. Becca and I then had the conversation about exercise. Specifically, how exercise-induced oxidative stress does vary depending on the intensity, duration of the exercise, as well as the individual's fitness level, age, and overall health. Since Becca had been leading a sedentary lifestyle, I explained that she'd likely benefit from adding some daily movement. On the flip side, I also cautioned her against over-exercise, which can increase oxidative stress. and told her that if she ever wanted to get into ultramarathons, taking a creatine supplement could help decrease oxidative DNA damage and lipid peroxidation caused by training. She, of course, asked why, and I explained that this is because most of your methylation cycle is spent creating creatine, so when you supplement, you can actually utilize this pathway for other things like DNA methylation. So, after the conversation, Becca decided to join a run club. She did this because 1, she'd always wanted to run a 5K but had never had time to do one, and because 2, she took Gretchen Rubin's 4 Tendencies quiz and learned that she's an obliger, which means she excels at fulfilling commitments to others, making her a reliable colleague, friend, and family member, but often finds it difficult to motivate herself for personal goals or projects. Joining Run Club built in accountability for Becca, which helped her run more regularly. Run Club had the unintended positive benefit of giving Becca more social support. It turns out, adequate social support and healthy relationships can act as a buffer against the harmful effects of oxidative stress. Social support can mitigate the impact of stress by providing psychological and material resources that help individuals cope with life's challenges, boost their resilience, and decrease oxidative stress. Becca eventually met her life partner at Run Club, and they lived happily ever after. Just kidding, that would be too good to be true. However, this is Becca's very satisfying final oxidative stress profile results. By the time she turned 39 years old, she'd lowered her score from 46.5 to 38.9. In summary, Vibrant's oxidative stress profile identifies 32 genetic variants affecting antioxidant enzymes and measures 16 oxidative damage markers. This provides insight into genetic predisposition to oxidative stress alongside real-time damage to DNA, RNA, proteins, and lipids, allowing for a comprehensive assessment of oxidative damage, antioxidant capacity, and overall cellular resilience. These, of course, are critical factors in evaluating the biological rate of aging and building a foundation for personalized longevity strategies. The report also features an easy-to-follow antioxidant flowchart and a damage markers infographic, along with an overall oxidative damage score, making it simple for patients to understand the results and empowering them to take actions towards better health. When paired with additional testing, the oxidative stress profile helps support the bioenergetic foundations of longevity. If you're looking for a full-service lab partner, Vibrant makes it easy for you and your patients. From one simple portal, you can order tests across a broad menu, more than 40 tests to choose from, all shipped in one box with streamlined instructions. Vibrant is a CLIA-certified and CAP-accredited biotech company backed by 400 clinical researchers and cutting-edge technology, including RT-PCR, mass spectrometry, and microchip arrays. We believe that anyone can achieve better health and vibrant longevity through individualized solutions based on testing and not guessing. Our peer-reviewed research featured in internationally renowned publications, including the prestigious journal Nature, has led to breakthrough products and services in celiac disease, allergies, autoimmune disease, tick-borne diseases, and more. And the support doesn't stop at testing. Concierge blood draws, complimentary clinical consults, and powerful diagnostic tools make it easy to integrate Vibrant Wellness into your practice. If you're ready to get started, signing up is easy. Creating a provider account takes less than 2 minutes. Simply visit vibrantwellness.com, click Sign Up, and choose Provider. Once verified, you'll get full access to the provider portal, test ordering, and also the new Vibrant Academy. And that's it. Thanks for your attention. Please let me know if you have any questions.